Morning, everyone. My name is Ron. I'm going to be your instructor. My day job is a physics professor in Baker University in Kansas, and for this class I'm teaching in MSU Billings, the online course. This is for the actual lecture part. There are going to be a few presentations for the lab part as well. Today, in this lecture, and every lecture should be about 20 minutes or so for you to go through the slides, maybe a little more, maybe a little less. In this lecture, there's just going to be a short overview of what physics can be all about. I'll have a few words to say on every slide, but that's about it. Maybe the most important thing for a student to come out of Physics 111 with is the idea of how science works. Whereas people think the scientific method is something incredibly clearly defined, that is not so. And yet science is the best tool we've ever had, the best tool we humans ever had. You'll notice here in this slide that some things are unexpected. For example, when you're thinking about explosives like TNT, which is a type of explosive, and a peanut butter cookie, you think that TNT would be way more destructive than a cookie. Ends up that you give this cookie to a few freshmen in MSU Billings and ask them to smash a car, and they'll do more damage than that 1 gram of TNT. Guess what? Our understanding of units is critical, and one of the most important units is kilowatt hours or petawatt hours, the units by which we measure energy. From the time we learned how to use fire and to the present, we are using energy to keep us alive. In the United States, as you can see, about 37.4 of the total electricity is being produced by coal. Next is gas, but these were way different just 5 years ago when coal was more than 50% and gas less than 15%. Things are changing. Alternatives were at about 2% 5 years ago, are now at 5.4%. We will discuss these and how they are related to physics. Power stations follow the laws of thermodynamics, which is a part of physics, and therefore there are some physical limitations on what we can expect from our energy production units. One significant part of your homework assignment will be an assignment that will be done with Excel. I will give you all the instructions on how to do those. They involve nothing but just putting in some numbers into a table. But by doing so, you will be the czar of the world for the next 30 years or so. And during that period, you will determine whether or not there'll be mass starvation, or mass pollution, or mass trouble of a different kind. Next, we will go for the understanding of how the macro, the mechanics and the thermodynamics, are connected with micro, the ideas that everything is made of atoms. That's again a part of physics. Speaking of E equals mc squared, this is an example where Einstein's law, in which energy may be derived by converting mass into photons, is used in something called fusion. This is part of Lawrence Livermore laboratory experiment that may be a breakthrough towards that kind of a power supply. Of course, energy has its nasty side as well. Here are pictures from 9/11, and next you will see a few pictures from atomic explosions that have been very devastating to us. A natural understanding that's quite different than mechanics or even the atomic to macroscopic connection is electromagnetic theory. And from electromagnetic theory we'll reach all the way to light. Picture, you are seeing gamma ray radiation from around the world. Think about a map of the world that's kind of smeared. After all, the world is round, but you can get a projection of that onto some sort of an oval shape. This is a sphere of the sky all around us smeared into oval shape, in which we see gamma ray radiation from across the universe. This is a somewhat simpler picture of the universe. It's just a small portion of the universe. It's called the Hubble Deep Field, and in it every single point except for 3 are galaxies rather than stars, are galaxies rather than suns like our own, which we call stars. These are used in developing the Big Bang theory, which is basically the Big Bang law. It's not just a conjecture, it's not just a hunch, it's the law. Here in our first lecture, last slide, you're seeing a few of the topics that I may end up covering towards the end of the class, and a picture of E.T. getting drunk. I'll see you in the next lecture. I finish every single lecture of mine with those words. May you live long and prosper.